Good afternoon, everyone. Thank you, Megan, for the introduction. Thank you for letting us present on this research project. My name is Tomasz Neugebauer. I'm a librarian at Concordia University and one of the investigators on this research project to design and build a browse and search interface for the metadata that we've been collecting about online literary performance in Canada. And so members of the research team will present in turn. So the presentation will begin with Jason Camlot, who's a professor in the Department of English at Concordia, describing the data collection. So the data collection was accomplished with the help of our custom Swallow Metadata Ingest System, which will be described by Francisco Berrizbeitia, who is a developer at Concordia Library. The usability research and front-end design for the interface will be described by Alexandre Bustamante, who's a graduate student in the Department of Design and Computation Arts at Concordia. And next we'll have Sukesh Gandham, a graduate student in the Department of Information Systems and Security, who will describe the custom-made data visualizations that were prepared for the interface. And finally, Ben Joseph, an undergraduate student in computer science at Simon Fraser University, will describe the technology stack that we decided to deploy, which was a research question for us in itself. And then we will proceed with some question answer. So I'll now pass to Jason Camlot.
Thanks so much, Tomasz. It's great to be here to participate in the Concordia University Library Research Forum. So my area of research is literary studies. I direct the SpokenWeb project, which is focused on the digitization, development, description, and study of literary events and performance that have happened in Canada since the 1950s as documented on audiovisual recordings. The current project, Archive of the Digital Present, is an extension of this interest in the importance of literary events and sort of telling literary history through the study of not print materials alone, but actually audible materials. And it's designed to gather information about what has happened to literary events and gatherings during the pandemic, when in-person gatherings become rarely possible. The shift from the cataloging and study of past events captured on analog recording media formats like reel-to-reel tape to the cataloging and study of virtual events during the pandemic has had an important impact on our metadata ontologies and the structure of the database system Swallow that we use to capture our metadata. And Francisco is going to tell you more about that soon. So when in March 2020, I began to notice that scheduled literary events were being canceled or postponed, I began to engage in gathering sort of qualitative accounts from literary practitioners and series organizers about how they were pivoting from live to online literary events and how it was affecting our communities in Montreal and then across the country. And key questions I was asking through conversations, doing oral histories with people, through autoethnographic and phenomenological sort of observation and writing were things like, how are we listening to each other now? How are we experiencing works of literature during the lockdown? What's happened to our literary communities when they cannot gather in person? How are new works being shared with audiences across artist networks? So this qualitative data resulted in a whole bunch of stuff, interviews, podcasts, papers, things like that. And the methods I was using are listed there. But really, I didn't know the extent to which this was impacting our communities across the country. What was the data on pandemic literary events in Canada? So drawing on an extensive metadata schema that we developed for the SpokenWeb project, we adapted it and created a streamlined crosswalk for this ADP project, selecting a limited number of key metadata fields that we felt would be most relevant. And you're sort of looking at them here as they're scrolling by, including creators and contributors, date, time and place of an event, referring to where the event was hosted from in this case, what digital platforms were being used for the event, genres of events, names of works read, and other things like that. So the data collected in these fields we felt would allow us to generate timelines and different kinds of visualizations about pandemic events, and also would inform further oral history interviews that we have been conducting and will continue to conduct as we gather more stories about this remarkable period of literary history. Our first data set was created by a research assistant, Selena Wiener, who I asked her to basically find as many postings for literary events that she could on social media. So that was our first source of information, Twitter or Facebook. As you know, so she gathered using our key metadata fields, gathered and organized it, and that's what you're seeing here. This was the first list, and she was able to identify nearly 80 organizations who'd organized hundreds of events during the first year of the pandemic. So this was our first phase of data collection. Once we received an internal grant and then a SSHRC Insight Development Grant, we were able to expand our data collection and our curation team. So we currently have 3 MA students and 3 undergraduate students gathering the kinds of information that we're seeking for a data set. In addition to adding data about each unique event into Swallow, our metadata ingest system, this team's also working on expanding the data set further. So right now, each of these RAs is working on a particular kind of organization that we'd identified from our initial list as having been very active in organizing literary events. And you can see these are the lists of new kinds of organizations that we've been finding: libraries, public libraries, literature departments, literary presses and journals, writers associations and festivals, etc. And this is significantly expanding our data set. The next phase will be testing the long list that we have created against literary communities themselves. So some crowdsourcing work will be the sort of final phase once we're able to make it available through the front interface. As I said, all this data is being captured in Swallow, which was in great part developed by Francisco, who's going to tell you a little bit about that now.
Okay, sorry, I was muted. Okay, so yes, I'm going to talk a little bit about Swallow. Swallow is a web-based, lean and flexible metadata ingestion system that we developed in principle to solve a specific problem presented by the SpokenWeb project. And the problem at hand was they wanted to aggregate a number of collections that were geographically dispersed, and they need to do it in not only that, they were geographically dispersed, and some of them were cataloged in different systems, and some of them weren't cataloged at all. So, and that was a problem. And it needed to be correct in a way that people can collaborate in aggregating these collections and building these collections, and also the schema Jason just mentioned is quite extensive, and it needs to be constant tweaking. So it needs to be very easy to change and update that schema. So with those constraints in hand, our solution was to come up with this sort of a bridge system or an aggregator system that consists of 3 main models. One that allows to batch import, to write maps that allows to import from various systems. An interactive cataloging user interface that would allow for like manual input of the previously uncatalogued collections, and that is responsive to the schema definition that is based on a NoSQL approach. That being said, it's like eventually what we did, we decouple the values from the structure in a way that is this engine can create the interfaces quite easily and still read the data from the database. Okay, so what it does makes very easy for us to make changes at the schema without breaking anything. And also an export model that allows to, by using filters, export the data to be used to, like, if we're going to see later on, to stuff like Strapi for doing a front-end application, like it's what we're presenting today, or to preservation layers like Dataverse, or to MongoDB for another like access point. And this kind of like sort of summarize a little bit what Swallow, the structure of Swallow. One of the issues, even though Swallow is quite flexible in how it works, there was a part of the system that is still was very specific to the SpokenWeb project, and you can see here in the slide that we have a hierarchy in which we have partner institution at the top, and that partner institution has many collections, and those collections have many items, and that was fixed. That top part of that, and we needed to, and out of this issue, like 2 solutions came out of this, like two outcomes. One was a crosswalk that allows to move forward with the project. So we map partner institution to archival present, we map collection to organization, and then we map some of the fields in the item to the new description. And that allowed us to move forward with the project. But also, this also like started the development of a whole new iteration of the Swallow system, which is something that it's quite interesting, because by virtue of being engaged in this project, we end up with like a completely flexible, full-out metadata management system that is actually currently being used in the library for all sort of things, from like powering the digital screens to the website and we're using for all sort of things in the library, which kind of highlights the value for us, at least from the development point in the library, to participate in these research projects. That being said, I'm gonna leave you with Alexandre, who's gonna talk about the UX research portion of the project.
Thanks, Francisco. I'll be presenting the process of the UX, or user experience in full, front-end design of the archive of the digital present. This design of the ADP was from an early phase directed as a user-centered project. But after the design was initiated, our discussions evolved for experimenting with a participatory design approach, which means that basically we design with the users and not only for the users. In some, it would mean that we would have a greater involvement of the stakeholders in all development phases of the design. And besides this participatory approach, the work planning was also based on the double diamond model that we can see here on the slide. And this method is it represents a process of research, ideation, iteration, and testing that's commonly referred in what people call usually design thinking. And it alternates divergence and convergence phases in which we explore a wide field of possibilities before narrowing down to A, definition of the problem to be solved by the design, and B, a proposition of or a solution for this problem. And by adopting this framework for the UX design, it meant that we needed to investigate with the stakeholders of the ADP their needs and motivations to use our tool. And for this, we have organized a series of workshops, participatory design activities, and user experience research that involved invited participants and the direct team of the front-end development as well. And those workshops, they adopted established UX design methods, such as, for instance, building personas or user journeys to help draft a map of the user's needs. And after we had better understood the needs of our potential users, we continued with this participatory approach through different online workshops that helped us come up with information architecture for the website. Card sorting, tree testing, and first click tests are some examples of workshops that were used for this. And as we had to adapt to the challenge of conducting workshops remotely during the pandemic, we explored some available tools that we had for such workshops, such as Miro boards, Google Jamboards, and Optimal Workshop, which is the one that's shown here on the slide. And from these findings of the series of workshops, we were able to propose an information architecture to the website that was later refined through several iterations. And we came up with a prototype that we wanted to test with the users. For this, we decided to use a no-code platform called Webflow to build a high-fidelity prototype. And differently than using static images or softwares that are dedicated to create mockups for UX design, that are usually limited in interactions that can be tested with the users, the use of Webflow will allow us to have an in-depth consultation with the stakeholders and possibly even to export the prototype directly for its development. For this prototype created on Webflow ended up being a fully functioning website on its own. which allowed us to test with the user several layers of interactions. And this was the second part of the UX research, the usability research, which was conducted together with our colleague, Eva Liu, in which we ran interviews with potential users of the tool, and we asked them to perform certain tasks on our mockup website. The results from this research phase fed the process of the iterative design, and it allowed us to get closer to a more finalized prototype. And after that, we would then move to developing the visuals for this project. And finally, we also took a participatory approach to the creation of the visuals and the look of the tool. And here on the slide, we can see some of the final screenshots of the design. Team members and stakeholders were invited to guide the creation of those visuals by reflecting on the pandemic and providing keywords that helped us build a mood board for the design work. And this process directed the design decisions to achieve a final result that aims to be characteristic and representative of its particular time. And our website's appeal also relies heavily on interactive visualization of data on our homepage. And this is a topic that will now be presented more in depth by Sukesh.
Thank you, Alexandre. Data visualization, it helps to tell stories by creating data into a form easier to understand, highlighting the trends and outliers. A good visualization tells a story, removing the noise from data and highlighting useful information. The UX design confirmed that we want to have interactive visualizations. How the data has been transformed, we wanted the visualizations to be 1, interactive, 2, based on the same libraries or tools, and open source. We choose D3 because it gives us all of that. D3.js is a JavaScript library for manipulating documents based on data. Data from Swallow is retrieved using the Python script. This data is then transformed to JSON or CSV formats for the purpose of visualization. The JSON formatted data is converted into an SVG image using Angular and D3. The SVG image is embedded into the web page. This is a timeline visualization. The usability survey identified event dates among the important metadata elements for the navigation of content. This visualization highlights how many events took place on each date and visualizes the timeline on a spiral. We added the ability to navigate to event metadata directly from the visualization by clicking on dates. The data transformation produces a file with the number of events per date. And then the second visualization, connections. The usability survey identified names of participants, names of organizers, and event titles among the most important metadata elements for the navigation of content. This visualization touches on all of these elements. The default data consists of Swallow records with multiple authors who have participated in the events. A single creator can participate in multiple events. The connection interface is a network visualization that uses edge bundling by event organizer for additional effect. It builds a network by connecting authors to events they participated in. Because of the size of the data set, hundreds of authors and events, only the top 10 authors with the most connections to the events are shown. And the third visualization, places. Here, the usability survey identified host location among the most important metadata elements for the navigation of content. Literary events were hosted in Canada online and few in person. We built the visualization by generating a map of Canada with D3 using a GeoJSON file describing the topology. We transform the Swallow data that includes host location into a clean CSV file with coordinates of each location and the number of events that took place there. We then use that data to add interactive clickable markers on the map, showing which cities hosted the events and allowing for navigation of event metadata by the city name. Now I'll pass it on to Ben Joseph. Thank you.
So while considering how to build the technology stack, we had to examine how the site was going to be used and the best way to facilitate those purposes. So the ADP had to be able to display a large volume of information and pass through that information in a relatively quick way. So it had to be able to scale up, not just in terms of being able to deal with more information as the archive grew, but also it needed to deal with more methods of filtering and displaying records. So perhaps most importantly, it had to be user-friendly and easily maintainable. The idea was that even a person with no experience with programming should be able to log in and change records on the front end. So for this, we considered several content management systems and options for front-end frameworks, eventually settling on Strapi, which is an open source headless content management system, and Angular, which is a TypeScript-based framework for building JavaScript applications. So talking about Angular, working directly with the DOM requires understanding many things about how the DOM works, how to make elements, how to change their properties, how to put elements inside of each other, how to get them on the page. Now, none of this code actually handles user interactions or address adding or deleting a task. If we add those features, we have to remember to update our UI at the right time in the right way. JavaScript frameworks were created to make this sort of work a lot easier. So they exist to provide a better developer experience. They don't bring brand new parts to JavaScript, but they give you easier access to JavaScript's parts so that you can build for today's web considerably faster. Then we come to Strapi. So the loading time of Strapi is relatively fast compared to other headless CMSs, and that's why we chose it. This is because it works so well with Angular and developing client-side applications. So Angular is a component-based framework which uses declarative HTML templates. At the build time, transparently to developers, the framework's compiler translates the templates to optimize JavaScript instructions and pushes that load onto the client side. So Strapi handles these requests and pulls data from a connected database to display on the front end. So traditional content management systems like WordPress consist of 4 parts. So it's the database, the admin panel, and integration for reading and writing, and the actual front end. A headless CMS like Strapi consists of pretty much the same thing, except for the front end, for which we're using Angular. Then we can talk about Melee Search, which is what we're using for our open source search engine. Which we picked it because it's just so easy to use and deploy. Now, the aim of Melee Search is to create a relevant search experience just out of the box in very few steps with almost no configuration. So for developers, Melee Search requires very little configuration. Communication to Strapi is done through a RESTful API. It's fairly well integrated with Strapi right now. The returned results are sorted according to like a set of consecutive rules called ranking rules. So it's highly customizable. You can delete existing rules, add new ones, or even change the order in which they're executed. You can also configure the search parameters to refine that search even further. So that's filtering and faceting. Now I realize I went over that relatively fast, but I'd be happy to answer any questions during our discussion.
Yeah, so I guess we can move on to the discussion, although we have very little time. I just would like to acknowledge the support of Shirk and the Faculty of Arts and Science at Concordia and Concordia University Library. And also like to thank all the participants, the publishers, writers, and literary organizers and scholars and the students who contributed their time during the usability workshops. And with thanks to the research assistant Eva Lou from the University of Toronto, who assisted with the UX design, and Ben Hines, the project manager. And we also like to thank the research assistant data collectors and processors who are curating the data in Swallow. So that's Selena Wiener, Aaron Obitkoff, Francis Grace Fife, Dia Powell, Olivia Hornacek, Theodore Fox, and Shakia Williams.